Hello, how are you, my dear students? Namaste to all. Today I am giving you very interesting lecture about the hydrogen bond. That is very important for knowledge as well as examination viewpoint. Yes. So at first we have to know what is hydrogen bond. Hydrogen bond. So what we see, it is a very weak bond in between hydrogen and high electronegative elements like fluorine. Its electronegativity value is 4.0. What is oxygen? Its electronegativity value is 3.5. And what is the nitrogen? Its electronegativity is 3.0 etc. So what we see when we talk about the definition of hydrogen bond, so it is a very weak bond formed in between hydrogen and high electronegative elements like fluorine having electronegativity value 4.0, oxygen having electronegativity 3.5, nitrogen equivalent what you see 3.0 etc. Yes. So we see example like this. H of hydrofluoric acid. Yes. H of hydrogen for one molecule, that is the second molecule H F. So what we say H, and that is what we say F. So what we see why? Now question arises why hydrogen bond is formed. So what you see of fluorine has electronegativity value 4.0, yes, and H has 2.1. So what you see, so according to definition of electronegativity, we know the element which has higher electronegativity value, it attracts the shear pair of electrons. So what happens over here? It develops slightly negative charge. H develops slightly positive charge. Slightly means partially. And the bond formed in between fluorine atom and hydrogen atom, that bond is known as, this weak bond is known as hydrogen bond. Yes, that is also hydrogen bond. Why? Because it has slightly negative, it has slightly positive, and bond angle is what you see 134 degree. Yes, so that is hydrogen fluoride. Yes, so what we see, hydrogen bond in between two molecules of hydrogen. One molecule, that is the second molecule, that is the third molecule, that is the fourth molecule. Yes. So what you see over here, hydrogen bond formed in between high electronegative element like fluorine, and what you see H. Why? Due to high electronegativity value of fluorine and low what you see 2.1 hydrogen, it causes what is a very weak bond, and that weak bond is known as hydrogen bond, HF. Like this, or water, that is water, that is also what you say water, H. Yes. So what we see, so oxygen has how much? 3.5. hydrogen has 2.1. So what do you see? It develops slightly negative charge. It develops slightly positive charge. Yes, over here slightly what do you say negative charge, it develops slightly positive charge, that is hydrogen bond. Why hydrogen bond is formed over here? The due to electronegativity difference of oxygen and hydrogen is what is very high, and it forms a very weak bond. The dotted line is known as weak bond, that is also known as hydrogen bond. So I think you have clear. So how hydrogen bond is formed in between two hydrogen atom. So generally hydrogen bond is formed in between the what we say hydrogen as well as high electronegative elements like fluorine 4.0, oxygen 3.5, nitrogen 3.4. That is what the electronegativity value. Yes, so that is about how hydrogen bond is formed. Next one is so now the criteria for hydrogen bonds. Next, criteria for hydrogen bond. So first criteria is the hydrogen bond form should be the elements, better to say elements should have higher electronegativity value. Yes, the first category, the elements should have higher electronegativity value, like fluorine we have already studied 4.0, oxygen has 3.5, nitrogen has how much 3.0, etc. So only it forms hydrogen bond in between the hydrogen atom and high electronegativity. The first criteria is the elements should have higher electronegativity value. Yes, first criteria. Second criteria is the size of the high electronegative value atom. The size of the high electronegative value atom should be smaller. Yes. So in all cases, what you see, hydrogen atom forms hydrogen bond with fluorine, oxygen, nitrogen. Now question arises, note, as a note we can say, question arises कि hydrogen, what you see, do not form hydrogen bond with chlorine in liquid state. One question is like this. So hydrogen does not form hydrogen bond with chlorine atom in liquid state of HCl, but nitrogen form hydrogen bond with hydrogen in bond with hydrogen in liquid state in ammonia molecule. So question arises why hydrogen atom does not form hydrogen bond with chlorine atom in liquid state of HCl, but nitrogen forms hydrogen bond with hydrogen in liquid state in ammonia molecule. So now question arises why. So why hydrogen do not form? Question answer of this question is, so the size of the chlorine atom. Chlorine atom is very large, so it does not form hydrogen bond in HCl in liquid state. Although what you see over here, although chlorine has electronegativity value is 3.0, similar to nitrogen atom, but it does not form hydrogen bond with Cl in liquid state. Question arises why? Because the size of the chlorine atom is very large, so it does not form hydrogen bond in HCl in liquid state, although chlorine has 3.0 electronegative value. Electronegative, but nitrogen, due to a smaller in size, it forms hydrogen bond with hydrogen atom in liquid state. Yes, so that is nitrogen, ammonia, so that is hydrogen, hydrogen. So nitrogen has 3.0 electronegativity value. Yes, hydrogen has how much? 2.1. That is the hydrogen atom. So that has slightly negative charge, that has slightly positive force. So what it forms? It forms hydrogen bond with hydrogen atom in liquid state. But chlorine does not form. Why? Because the size of the chlorine atom is higher. So two criteria over here. One, those elements which form hydrogen bond with hydrogen must have greater value of hydrogen, electronegativity value. Yes. And second criteria is the size of the atom must be lower, not larger. If larger, it does not form hydrogen bond. Like hydrogen does not form hydrogen bond with chlorine in HCl in liquid state. So I think you have clear. So why hydrogen does not form hydrogen bond with chlorine atom in liquid state of HCl, but nitrogen forms hydrogen bond with hydrogen in liquid state in ammonia molecule. Why? So you have already clear, size of chlorine atom is higher or larger, so it does not overlap the what you see electrostatic force of the what you see nitrogen. So it does not chlorine, so it does not form hydrogen bond. So I think we have clear why ammonia does not form. Ammonia form hydrogen bond with hydrogen in liquid state, but chlorine does not form hydrogen bond. Why? Due to large size. So I think you have clear. Yes. So always we have to keep in mind. So why chlorine does not form? What is the hydrogen bond? Although chlorine atom has 3.0 electronegativity value. Yes. So next one is type of hydrogen bond. So two types: intermolecular hydrogen bond and intramolecular hydrogen bond. Yes. So first one is what is the intermolecular hydrogen bond. As the name suggests, intermolecule. So in between two molecules. So intermolecular hydrogen bond. So what is the hydrogen bond formed in between two molecules of same compound or another compound. For example, when we talk about what you see oxygen, that is the H, that is the water molecule. So when that what you see, the name of this compound is acetone, organic compound acetone. So what we see? So oxygen has what you see negative charge, it has slightly positive charge. So that is what you see, oxygen has 3.5, hydrogen has 2.5 electronegativity value. So what you see oxygen develops slightly negative charge, hydrogen develops slightly positive charge. So what you see over here? Hydrogen bond. In this case, what we observe over here? Water molecule, that is the acetone molecule. Two different type of compounds. In between two molecules, you can say. So the first molecule is what you see water, second molecule is what you see acetone. First example. Second example is nitrogen, hydrogen, that is the first molecule, that is the second molecule. So what you see again over here, there is what you see, it has slightly negative charge, it has slightly positive charge. So what you get? Hydrogen bond. So such type of hydrogen bond is known as intermolecular. Maybe same molecule, ammonia is same molecule. So what do you see over here? That is ammonia. First molecule, that is the second molecule. Maybe same molecule, maybe different molecules. So what do you see over here? So the water, that is the acetone, organic compounds. So what there is formation over here? Hydrogen bond. So that is dotted line is what you see, hydrogen bond. Yes. So you have clear what type of intermolecular hydrogen bond. Next one is what you say, intra, as the name suggests, intramolecular hydrogen bond. If the hydrogen bond is formed, hydrogen bond is formed in the same molecule, is known as intramolecular hydrogen bond. Yes, so example is like this. So hydrogen bond, example is like this. We have heard the name of what you see, that is benzene. That is benzene. So that is what you see, OH. That is nitro group. So what do you see? Oxygen. So you know 2.1, 3.5. So what do you see? So intramolecule, same molecule. And what the name of this compound? Orthonitrophenol, same molecule. So what is that? Is OH. That is a nitro group. So in this case, oxygen has 3.5, hydrogen has 2.5. So what do you see? It slightly develops positive charge. Oxygen develops what you see, negative charge. So what do you see? So there, what you get? Very weak bond in between oxygen and hydrogen. So that is known as what type of hydrogen bond? That is intermolecular, not intermolecular, but we can say intramolecular hydrogen bond. Yes, same molecule. It is the same molecule. Yes, one example. Second example is salicylaldehyde. That is HC double bond H. Again, it has positive charge, it has negative charge. So that is known as salicylaldehyde, same molecule. So hydrogen bond, that is hydrogen bond. Why it forms hydrogen bond? Because oxygen has 3.5, hydrogen has 2.1, what's in negativity value. So when we talk about the type of the hydrogen bond, what do you see? If the hydrogen bond is formed in the same molecule, or we can say two different molecules of the same compound, that is known as intermolecular. Second one is intramolecular. If the hydrogen bond formed in the same molecule is known as, so what do you see? Same single molecule. So in this case, what you get? That is OH group, that is the nitro group. So what is the name of this compound is orthonitro. That position is known as ortho, what do you see? Meta, para, meta, ortho. I will talk later about this orientation of the ortho, meta, para. So what type of compound it is? Orthonitrophenol. So nitro position is ortho position. OH, that you know, phenolic group. So orthonitrophenol. So in this case, the bond formed in between oxygen and hydrogen, what do you say? That is known as intramolecule. Why it is known as intramolecule? Because hydrogen bond is formed in the same molecule. In this case, again, salicylaldehyde, that is very important. organic compound from which we can prepare aspirin tablet, you know. So that's very important compound in organic chemistry. So what you see again, oxygen has slightly negative, hydrogen has slightly positive. So in between, so what you see, get very weak bond, and that weak bond is known as hydrogen bonds. See, yes. So thank you for this watching this interesting video. So later on I will talk about next slide. I will talk about the what you see its what you see type is the nature of the bond and what is its application. So I have already mentioned the what you say type. So application is very important. Why we study what you say hydrogen bond. So due to presence of hydrogen bond, molecule have what you see slightly high boiling point. It is more soluble in water. What you see it is what you see. I will talk about later on what you see. Its application, effect of hydrogen bond in the molecule. Yes. So I think you have already done subscribe and also convey students, friends, what to say for learning. So again I will start for next what to see.